Okay, we have lesson 1-3 here that we're going to go over, and some of the big ideas from that lesson. And you can see it's called number sequences. So in a simple way, I mean, when you count, you have a number sequence. 0, 1, 2, 3. You know, what's the next one, and what's the one after that? Well, we know that each time we're adding 1, right? So we could say that 3 plus 1 is 4, and 4 plus 1 is 5. So that's a real simple example of the big idea here. And we might do things backwards like that. Like say we went 5, 4, 3, and then asked you for the next ones. Right? We could do the same thing. We're subtracting 1, we're subtracting 1, and we're subtracting 1. So we would get 2 and 1. So let's see. So, but we can make these bigger too. We could also say we could do 1, and we can see the pattern here if we look at it a little more closely. And we're going up. Now it's not addition, but it is multiplication. We know the numbers are increasing, so it's not subtraction or division. But we do know that it's multiplied by 2. Multiplied by 2. So 8 times 2 is 16. 16 times 2 is 32. We could do that the other way also, obviously, if the numbers were 32, 16, 8, and we asked you for the next few. We know that they are going down, so it has to be division or subtraction. And in this case, to me, looks like it's division. I know 16 is half of 32, 8 is half of 16. What's half of 8? That's 4. What's half of 4 is 2. So we are dividing by 2, dividing by 2, dividing by 2, cutting these in half. So this is the lesson here, lesson 3, and I'll read the introduction to you. Sequences. So far in this unit, you've learned to recognize different classes of functions and different patterns and tiles. In this lesson, you will learn that there are different types of numerical patterns that match up with classes of functions. You'll also learn rules for distinguishing amongst linear patterns, exponential patterns, and patterns that are neither linear nor exponential. So let's just do some of these, this class example here. Find the next 3 numbers in each sequence. So when I'm thinking about these and I'm looking at them, let me make this a little bit bigger here. All right, I'm going to say, well, 2 to 5. How do I get from 2 to 5? And I know I'm going to add 3. And then does that work for the next one? 5 to 8. Can I add 3 there? Yep, I can. And 8 to 11. Great. So I know that we're adding 3 here. So 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20. Next one, number 2. This is also increasing. And that's the first question you should ask yourself. Is it going up or is it going down? Are the numbers getting bigger or are the numbers getting smaller? So I'm looking at this, and I'm going to follow the same line of thinking that I used for the last one. I'm going to say 3 plus what gets me to 6? And 3 plus 3 is 6, so the next one must be plus 3. But 6 plus 3 is 9, not 12. So it's not addition, is it? But if I go back and look at it again, how else can I get to 6 from 3? And I could say that 3 times 2 equals 6. And 6 times 2 equals 12. So there we go. There's our pattern. We're doing 2 times by 2. Times by 2. So 24 times 2 is 48. And what do we got there? 96. And 180 and 12, 192. Okay, feel free to use a calculator when you get some of those bigger numbers. It's faster and more accurate. Okay, let's see here. The ones that go down. Let's look at these. Number 3. The numbers are going down. Again, that's the first question. Are they going up? Are they going down? Bigger or smaller? And they're going down. 10, 8, 6, 4. We know this one. 2, 0. And then after 0, It's really cold outside. Just imagine it's -2 degrees. Oops. Oh boy. Let me just go back there. We had a little technical difficulties. 10, 8, 6, 4, 2, 0, -2. And we're going to do the same thing over here. It's going down, but like the one above, it's not addition or subtraction. In fact, it's the opposite of multiplication, which is division, and these are cutting in half. 32, 16, 8, 4, 2. What's half of 2 is 1. What's half of 1 is a half. All right. Let's see. Now explain what the rule is for getting each number in problem 4. And we divided by 2. Some good definitions for you right here. And I want you to take a look at those and then answer these questions here. So next page we have some directions and we're at the guided practice. Whoops. So for each sequence below, determine the next 3 terms. That's 1. Find a rule that allows you to get from one term to the next, then label the sequence linear, exponential, or neither. And so when I look at these numbers, I see 1, 2, 4, 8, they're going up, and they're being multiplied. They're getting twice as big, multiplying by 2. So rule, multiply by 2, and that, folks, is exponential. Now we have a few here to do. You have 5 of them. I'm just going to do one more here, and then you're on your own for the rest, okay? This one here, let's see. Let's blow this up. Number 2. I see 1 to 4, 4 to 9, 9 to 16. So they're going up, but it's not a straight addition or multiplication here, because this one is going up by 3, and here to here is going up by 5. But this one's going up by 7. So this must go up by 9. So 16 plus 9. Oh boy, let's see here, 25, that's right. And then the next one's going to go up by 11. That's going to get us to 36. And then up by 13 is going to get us to 49. There's actually something quite special about those numbers right there, too. And I'd love for you to tell me what it is sometimes. But this is neither. Okay, and I'm going to leave you to do the rest of these ones on your own here. Okay, and let us know, as always, if you have some questions.